Alright, so last time we left off with our calculation for molar mass of propane using our little equation. So we have to measure the mass of the propane. We have to measure the volume of that mass of propane. We have to take the temperature and pressure and then plug it into our little equation to come up with the molar mass of propane. So that's what we're going to do. Now this is our little experimental setup for doing that. So this is a regular old flask to which you've got attached a little cork, and the cork has a little piece of glass coming out of it. And then you've got another little cork, and then you've got this thing that you can use to pinch close the piece of tubing. So when this is closed like this, the tubing is closed, and you've got another little piece of glass that comes out this end, and then you're going to attach this to it, and then you're going to stick this onto the propane. The propane is actually the gas that we use for all of our Bunsen burners. So we're going to attach this to the Bunsen burner outlet. Alright, now there's a little piece of glass up here, so if you slip this down on top of the glass, it's actually open because this thing is not pinched, because you can actually pinch this closed. But if this little metal thing is on top of glass, the glass is holding the tubing open, so it's not closed. But if you slip it down here, it actually pinches that tubing closed. Alright, so what we're going to do is we're going to fill this little area with propane. So we're going to open it up. We're going to connect everything up to the propane outlet. We're going to let the propane flow in. We're going to fill this all up with propane. You can't really see it, but we're going to leave it in long enough so that it fills with propane. And then we're going to close it up. And then we're going to measure the mass of this. And then after we measure the mass of this, we're also going to measure the volume of this area where the propane was located. And we're going to do that by just filling it with water. And then we've got the mass and we've got the volume. Now you might think, oh, well, this sounds pretty easy. All you have to do is just measure the mass. And how would you measure the mass? You just use a regular old balance and measure the mass, and there you are. But actually, it's a little bit more complicated than that. The reason why it's more complicated than that is because when you measure the volume in your little Erlenmeyer that has presumably nothing in it, this actually has in it air. That's the difficulty of measuring the mass of the propane. Now you're going to displace the air and replace it with propane. And you can measure the mass of the flask plus the air, which would be just the regular mass of the flask. And then you can weigh the mass of the flask plus the propane. But how do we know what the measure of the mass of the gas is, mass of the air is within this container? How do we know that? Well, the volume is easy enough to figure out because you just add water to it. You look at the amount of water you've got, and you can figure out the amount of the gas that you can fill this with water, and you can figure out the volume of the water. But how do you get the mass of the air? Well, this is actually why this is not that straightforward a lab as far as calculations go, although it's a very easy lab as far as the actual experiment goes. So here's a lab report form. And as I said, you probably can't read what it says in the lab report form because I can't zoom in that close and it doesn't focus that well with my webcam. But let me show you what's here. So what you're going to do is you're going to do this. What you're going to do is essentially, in a nutshell, you're going to measure the density of air. And you can measure the density of air by getting the temperature and pressure of that air. You're going to measure the volume of that air, and then you're going to use that volume of the air in order to calculate the mass of the air. So that's what we're essentially going to do. All right, so before we get to that, how are we going to do the little calculation to come up with the mass of things. So I'm actually going to give you some numbers that you need for your experimental calculations, and you're going to use these numbers to do the rest of your calculations. All right, so I'm just going to give you, you're supposed to have a flask number here. I don't care whether you put something in there or not. It really doesn't matter. And then we're going to add in the mass. This is the mass of the flask with air. This is the mass of the flask with air. The mass of the flask with air is going to be 153.4742 grams. So we're actually using the analytical balance in the back room to do this measurement. Okay, so this is the mass of the flask with propane. So how do we get the mass of the flask with propane? Well, you just displace all the air by blowing in propane into the container. The mass of the flask with propane is 153.6503 grams. Okay, so there we are. The temperature of the gas in the flask, we're going to use 22.0 degrees Celsius. The volume of the flask, and how would you get the volume of the flask? So this is temperature. So this is volume of flask. The volume of the flask is going to be 246.2 milliliters. And how do we get that? We displace the propane by water, and then we just use a graduated cylinder to figure out the volume inside the flask. The barometer reading is 760.4 millimeters of mercury. And where we get that, I read that for the entire class. And then there's a little program within on the computers on the third floor where you can input the temperature. So if you input the temperature and you input the pressure, it will give you the density of dry air. So this is the density of air at T and P. At T and P from above. So the density of air is 0.001197, and the units are grams per milliliter. Okay, so there we are. Now this is the actual only experimental part that you need for part 2 of this experiment. So this is chart 3. So this is chart 3. This is our part 2 of the experiment. So this is part 2. Part 2 is not really related to part 1, but this is the thing that we're doing. All right, so once we have that, then what we're going to do is we're going to go and complete our other part of the chart. This entire chart, chart 4, this is chart 4. This entire thing is all calculated. This is all entirely calculated. Okay, because we have all the other experimental data in chart 3. So we're going to use the data from chart 3 to come up with all the numbers that we need in this part of the chart. Okay, so then what we're going to do is we're going to look at what we've got here. So the mass of the air. So this is mass of air in flask. Mass of air. How are we going to get that? I'm not going to actually do the calculation for you. This is where you're going to show work. Showing work is worth 2 points. Actually coming up with the actual value with the correct units is worth half a point. So it's actually worth more to show work than it is to come up with the final correct number. Because I can't really tell by looking at your number usually if you actually did your calculation correctly or if you did your experiment correctly, and I really can't tell. And you're going to get, as long as you input the data that you get, as long as you come up with the correct calculation, you get almost all the points. I'm not going to count off for experimental error, especially not in this case because I'm providing all the experimental data. So how are we going to get the mass of the air? What we're going to do is we're going to take the density of air and we're going to multiply it by the volume of the air. The volume of the air must be in milliliters, and my density must be in grams per milliliter. Otherwise, when you do the calculation, you won't get the correct number. So we're doing density of air from our previous chart times the volume of the air in milliliters from our previous chart. You multiply them together, and you're going to get the mass of the air. All right, so next we have the mass of the empty flask. And what's the mass of the empty flask? I can't emphasize this enough. It's the idea that you have a dish. In this case, you have a flask. When you measured the mass of the flask, you had the flask plus the mass of the air inside the flask. So in order to get the mass of the empty flask, so this is the empty mass of empty flask. What you're going to do is you're going to take the mass. Let me just use a different color pen because I had to write the previous chart stuff down here. So all you're going to do to get the mass of the empty flask is you're going to take the mass of flask with air So this is the mass of the flask with air from our previous chart. We're going to subtract that by the mass of the air. And where do we have the mass of the air? Mass of the air is what we have up there. Mass of the air. Mass of the flask with air minus mass of the air. And where are you getting the mass of the flask with air? That's from our previous chart. Read what it says from our previous chart. Let's look at that. Mass of the flask with air. Mass of the flask with air. And then we're going to subtract the mass of the flask with air by the mass of the air. Mass of the air is from above. Okay, how are we going to get the mass of the propane? So this is mass of propane. Our mass of the propane is going to equal the mass of flask plus propane minus the mass of the flask. Where is our mass of the flask? This is the mass of the empty flask. So this is the mass of the flask empty. So where are we getting that from? Mass of the empty flask goes right there. Mass of the empty flask. Okay, so mass of the flask plus propane minus the mass of the empty flask. All right, so here, pressure in atmospheres, we just have to convert from pressure in millimeters of mercury to pressure in atmospheres. And how do we do that? To go from millimeters to atmospheres, all you have to do is divide by 760. Okay, and you're going to show the work there. Temperature in degrees Celsius to temperature in degrees Kelvin. So temperature in degrees Celsius plus 273.15 is going to give you temperature in Kelvin. This is volume in liters. How are you going to get that? All you have to do is you take the regular volume in milliliters, and you know that there are 1,000 milliliters per liter. So then you're going to be able to get the volume in liters because our milliliters will cancel out. And then you're going to plug everything into your calculation. You're going to show your calculation for your answer number 2 in the question number 2 below. So you're going to put your calculation here into the next question. You're going to come up with the molar mass for the theoretical calculation of propane. I already gave you that. So this is molar mass for C3H8 theoretical. This is percent error. If you read the lab report form, you will see that I gave you an equation for that. It says theoretical minus experimental absolute value divided by theoretical times 100. So that's going to be your percent error. And you're going to show me the work for percent error there. Okay, so that's actually your entire lab report form. What kind of stuff can I ask you on the mini final about this kind of stuff? Now, I almost gave you exactly what you need to come up with the answers for the numbers that are in the chart here, and this entire chart is all calculated. But if I ask you something, I mean, this is really common sense. If you have the mass of the empty flask, and you have the mass of the flask with air, and I subtract off the mass of the air, would that not give you the mass of the flask? So it's that kind of very commonsensical kind of things that we're looking at. Okay, so we'll continue this in a minute.